So let's talk about a technique called partial fraction decomposition. And for today, just for a little while, we're going to take a step away from integrals, period, and we're just going to do some algebra right now. I'm just going to do some algebra. So to begin with, let's do a little review exercise where we add together these two fractions, 3 over x plus 4 plus 2 over x minus 3. Now, whenever we're adding fractions, we need to make sure that they have the same denominator. So we go through and we insert a common factor of x minus 3 into the left-hand fraction, common factor of x plus 4 into the other fraction. Now we get the least common denominator, the product of x plus 4 and x minus 3 in the bottom here. Now we just go through and we clean up and we simplify the numerator. So negative 9 plus 8 is negative 1. The question that we'll be dealing with today is how to do this process in reverse. If someone gave me this quantity and asked me to unadd the fractions and to split them apart, how could I go about such a process? We'll be considering this question in 3 primary cases, and case number 1 will be the simplest of all. Case number 1, you're dealing with a rational expression where all the factors of the denominator are linear with multiplicity 1. So let's take, for example, just a very simple 4 over x plus 2 times x minus 7, say. Suppose that I wanted to unadd and deconstruct this linear equation as a sum of 2 simpler linear expressions. Now, motivated by my previous example, I think that it might be reasonable to guess that this would be split apart as 2 fractions, one with the denominator of x plus 2 and one with the denominator of x minus 7. Because if I did add these 2 fractions back together, then that x plus 2 and x minus 7 would be multiplied together to give me that least common denominator. And maybe, as in my previous example, it's reasonable to expect that there will be some numbers in the numerator here. As before, there was 3 and 2, so let me just say that there is a and b in the numerators of these fractions. So, if that is the case, if I can split this apart and get a format that looks like this, how can I find the exact values of a and b? Well, the first thing that I think I will try and do to find the values of a and b is I will try clearing the fractions. What do I mean? I'll try multiplying both sides of this equation, multiply by the least common denominator, x plus 2, x minus 7. Now, if you multiply the leftmost fraction by x plus 2, x minus 7, the entire numerator and the entire denominator will cancel out, leaving just 4. If you multiply a over x plus 2 by x plus 2, x minus 7, then a will remain, the x plus 2's will cancel each other out, and x minus 7 will be left in the numerator level. Likewise, in the final position, b will remain, the x plus 7's will cancel, and x plus 2 will be left uncancelled next to b. Alright, now at this stage, what happens if I multiply everything out? 4 equals ax minus 7 times a plus bx plus 2 times b. If this happens, I end up with terms that fall into 2 categories. I have terms that are constants, 4, negative 7a, and 2b. And I have terms that are linear, a times x plus b times x. And a and b need to be chosen in such a fashion that the left side and the right-hand side of this equation really are the same. What that means is that if I add together the amount of x's that I have on the left-hand side, that should match the number of x's that I have on the right-hand side. Namely, I don't have any x's. And if I add together the constants that I have on the left-hand side with the constants that I have on the right-hand side, those two sums, negative 7a plus 2b on the left and 4 on the right, the number of constants also has to add up to be the same thing. Now this is a system of equations, two unknowns. The first equation implies that a and b are exactly opposite. And if I sub that information into equation number 2, then I will get negative 7 times not a, but negative b plus 2b equals 4. 7b plus 2b equals 4. 9b equals 4, and therefore b equals 4 over 9. And therefore a equals negative 4 over 9. So what have we learned? We have learned that in the case that a is equal to negative 4 over 9, b is equal to positive 4 over 9, then the fractions on the right-hand side of this equation added together really will equal the result on the left-hand side of this equation. And I encourage you to go through and to check. Add together these fractions on the right-hand side and check and see that it does in fact simplify to this fraction on the left-hand side. Now this is the simplest example of partial fraction decomposition. In the future videos, we'll be talking about how to deal with more complicated examples of partial fraction decomposition.